Hello everyone, good morning. This is Kanav. I am a sixth semester computer programming student from T127 program. Here I'm back with another assignment of data science. And like I have been doing always, I'll be going over 10 questions provided in this assignment. As you can see, I have all of the 10 questions coded here in the Python language. I'll be going over the 10 questions we are given by our professor, and I'll be explaining how we have gone through the assignment, right? So for this one, we were given an iris.csv file by our professor, which was available on our Blackboard. So I just downloaded the file from the Blackboard, and then we were like kind of, basically supposed to connect our Google Drive. In the very first step, as you can see, I have imported Drive and I have connected Google Drive and the content slash drive folder. Okay, drive has already mounted. Okay, you can clearly see it says that the drive is connected to the collaboratory, which is what we were supposed to do, right? And then in the next step, we are supposed to upload the iris.csv into the Google Drive, right? So how we do that? We can either just copy paste it. Like what I did, I just downloaded the file, I dropped and dragged it into my Google Drive, and I dragged it into my collaboratory folder, which is the collab notebooks. In the next step, we are supposed to import like pandas. As always, we're using this directory, and the file name, this is our file name. So you see we have just given the path that iris.csv is available in so and so path. Then we are supposed to read the content for iris.csv file and set it in a variable named iris, right? So we just set up a variable iris, and the contents in iris.csv are now stored in the variable iris. Next, we're supposed to show the first five rows of data frame, and always, as always, the first five we just use iris.head. We did all the first five, right? In the next one, we are supposed to convert the column strings to integer as Setosa 0, versicolor 1, and Virginica 2, right? That's what we do here. We go iris, species, and then we set it on the map as this. This is the code for how we do it. And then when you run it, you check the first five elements again, you see there's a little change, right? You see species 000, Setosa, Setosa, Setosa. You see that change? Setosa was set to 0. Then we were supposed to select the first four columns of the data frame as the data and call the data X. So we called the data X and selected the first four columns, and we just called out the data X when the data ran. This is how the result came. Then select the last column as a label and call it Y. The last column, you see the last column, we mention it as Y, and it is equal to iris.ilog, iLocation, which is the last column. Okay, and then there it is. Moving on to the next question. Now it is the time to split data X and label Y into training and testing segments and call them parts X underscore train, X underscore test, Y underscore train, and Y underscore test. How we do that? We do from sklearn.model underscore selection import train test split. So we are going to import the train and test split, which is going to help us split the data X and the label Y into training and testing segments. Then we split the data, label the training testing segments, while size of the test data is 20%. Okay. Now it's simple. We just set the size to 20%, which is 0.2. Since 20% is 20 over 100, which ends up with 0.2, right? So we name it as X train, X test, Y train, Y test, and we train test split them with the test size of 20% and the random state as 1 to 3. Awesome. Moving on to the next step. We are supposed to check the first five rows of this training and testing set now. And how we check it is for the train, we go X train, this is the first five. For X test, this is the first five. For Y train, this is the first five. And for Y test, this is the first five. It's basically a simple command Y underscore train, X underscore train, X underscore test, Y underscore test, whatever you're looking for, parentheses from 0 to 5. Okay. Then moving on to the next question, we have checked the length of X train and X test. If the numbers are 120 and 30, awesome. Right, you're good to continue if the numbers are 120 and 30. So we check the length of X train and we check the length of X test, and the results turn out to be 120 and 30 like mentioned. So we are good to go. We are so good here, right? We are just moving to the fifth question. And it's like, this assignment was pretty simple. If you see, we have already reached the middle of the assignment, the fifth question, and we haven't had any complications so far. It's like basic commands, right? Like very basic commands. Then we have convert Y train and Y test into categorical and call them one hot train labels and one hot test labels respectively. Now we have to import categorical to underscore categorical like it's mentioned. Then we just convert one hot train labels as Y train categorical and one hot test labels as Y test. Sixth question seems to be pretty long, but it's not. We have to define sequential model that contains three dense layers. Okay, and in the first and second layers, we're supposed to use 100 hidden units. For the last layer, we're supposed to use 3 as the number of output, and so and so and so. For that, we have the command from keras import models, from keras import layers, and then models is the models sequential. Then we add to the model, like mentioned in the first step, the second, and the third. For the three steps of the question, we have three different lines of code. Which one works together gives us the result. Then, now please compile your model using RMSprop and appropriate loss function and accuracy for your metrics. We are already given how we are supposed to use the optimizer. We are supposed to use RMSprop, and we just use the RMSprop and we come up with the metrics as accuracy. We fit the model using epoch 20 and batch 10. We fit the model with epoch 20 and batch 10, and we get this long result right there. Then we calculate the result evaluating your X test, one hot test label, and see how accurate the model works. Upon working on that model, we find the test loss as 0.1816 and test accuracy at 0.89999, which is pretty close to 0.9000 and 0.1816, which is the right one. Perfect. Then, now we repeat all we have done in step 6 and we follow in parameters. So, like I have been talking to you guys about the sixth step where we use Relu, and Softmax. Like you remember, it's just like done. We use the same thing. We do the same question basically, but with two different conditions this time. Upon adding those two different conditions, we'll be running same keras models, keras import layers, going through model sequential, just making sure that there are 10 hidden layers, 10 hidden units, and the ReLU activation function. And upon that, we find this result, which is our ninth question. Then we're supposed to fit your model using epoch 4 and batch 10 like we did epoch 20 earlier. We're going to do epoch 4 this time. And this is the result for epoch 4. We are supposed to calculate the result evaluating your X test, and again the same thing. It's just that it was the previous one was Y and this one is X. Then whatever we have explained, whatever we have learned from this assignment is explained right here. You can very well read my answers. My answers talk about everything. I'll be going over a few of them, not all of them. Let's say we talk about how can we find and manage overfitting. So by analyzing whether or not model matches fresh data as well as the data used to estimate the model. This is known as the cross validation in statistics, and it is frequently entails splitting of your data, right? That is what we have learned. Now, if I say how the number of layers or hidden units could impact the accuracy, increasing the number of hidden layers may or may not enhance accuracy. It all relies on the complexity of the problem that you are attempting to solve. Simple, right? Nothing hard or nothing to worry about. The next one, the last question, please try a different setting as we did in question 9, and you can change the number of layers and everything. So basically repeating the question 9 and changing the parameters one at a time, and we come across multiple different results and share the experience. So in my experience, I would say more the hidden layers, there is a little, more accuracy, but at the same time, I would say that changing the parameters gives us pretty much the same that the result would be like, much more detailed than the previous one. And I would say that's all for this assignment. I hope you guys liked my work and see you next time.